Sid. Can everybody hear me?
Yeah.
Okay. So what I'm going to talk about today, it's interesting this is an event on the future of search, but I'm not actually going to tell you what the future of search is because I don't know. So what I'm going to tell you is how you can take your ideas, because I think there are a lot more ideas in this room about what the future of search is going to be than I or anybody at my company is ever going to come up with. And I'm going to talk to you about ways that these ideas can be tried and developed without having to have $1 billion to throw at the problem. So with that as my goal here, who is Alexa? We were founded in 1996. We're into our 11th year now. We were founded in 1996 by Brewster Kahle and Bruce Gilliatt. And if you haven't heard of Brewster Kahle, he's also the guy behind the Internet Archive right now. And he was one of the founders of a company called Thinking Machines, one of the early supercomputer companies. And so it was founded by Brewster and Bruce. And the idea was to use community to try to organize the web, to look at people's browse histories and link structure and content of pages and try to come up with some idea of what's important on the web and what's not. And if you think back to the web in 1996, there was no notion of page rank or so forth. Keyword spam was common. If you searched for travel agent, you would have no idea whether you were looking at a site the size of Expedia or some guy in his basement. And so what we wanted to do was bring to that problem the notion of people say this is great and people say that's not great. People go here, they don't go there. People who liked this liked that, that kind of an idea. So it was a navigation service based on community. And in the 10 years since then, we were acquired by Amazon. We took all the data that we were previously serving in a toolbar and made it available as web services. And we took all the content that we were crawling from the web and made it available as a web service as well. And a little over a year ago, we launched something which we called the Web Search Platform. And I'll talk a bit more about that. This is where we're located. We're just south of the Golden Gate Bridge in the Presidio, which is a terrific location. You can see our office up there in the right-hand corner. It's not much to look at. There's not very many of us. But this is where we keep our computers. So this is a little bit more confidence-inspiring. This is just underneath the Bay Bridge as you enter San Francisco from Berkeley, 365 Main. So we've got over 1,000 computers located here. We used to have them in our back office in the Presidio. We had them in our basement in the Presidio. We had them in Santa Clara. We've moved them all around, but this is where they finally ended up. And this has been basically what we've been doing, our workflow for the past 10 years. So we started off, since we had none of this stuff, we started off crawling the internet, which is not an easy thing to do. We started this back in 1996. We saved it, and we still donate it to the Internet Archive. So they've got something close to a petabyte of data that we've donated to them over the past 10 years, an ongoing record of what was on the internet. We analyzed that data to come up with this site is like that site. This is the language of sites. These are the top sites in various countries, top sites on various topics, and so forth. And then we serve that to our users, who could be toolbar users. They could be people visiting our website, people using other people's websites. And then we collect web logs, which then drive our crawler and drive our analysis. And this just goes around and around, and it's been going on for 10 years. So we've gotten very good at crawling, archiving, analyzing, serving, and operations. So that's the core of our business. In addition to that, we get asked to do a lot of additional things. And back in 1997, we were asked, or in 1996, we were asked by the Smithsonian to archive all the websites related to the presidential election. And the idea was that we didn't want politicians to be able to go back 3 years later and say, oh, I never said that. That wasn't me. This would be a permanent record. And we've done that for every presidential election since. It's not core to our business, but it's the kind of thing that would be hard for the Library of Congress to do, for example. Crawling the web isn't that easy. We also get asked for custom reports, top sites in different categories and so forth. And these, again, are hard for people to generate. It's hard to do via a search engine, for example. But if you've got all that data available to you, then you can come up with these kinds of custom reports. And what you see over here, this is a copy of the web from 1997 that we donated to the Library of Congress. This was all of 2 terabytes, every page we could find back at the time. Our collection has certainly grown since then. You can see that we're now up to 300 terabytes and about 10 billion documents. And collecting that volume of data certainly has its challenges. But it's really necessary. We didn't collect these for the fun of it. If we could have gotten by with just 2 terabytes for the past 10 years, we would have. but it's very difficult to do web scale analysis with a collection that small. So we wanted to have something to say about every site on the internet and hopefully every page on the internet. And if you compare here the size of the Trek terabyte collection to our collection, you can see the different scale here. This looks a little bit like Mercury passing in front of the sun, and that's kind of the difference in scale that we're talking about. And as I said, we get these requests fairly often for different slices of the web or different types of data, or can you help me with this idea? And we just don't have the people to answer all these questions. So what we wanted to do was make available all the data that we've got, the computers that we've got, the operations skill that we've built, make that available to people with ideas so that they could go and do it on their own. We wouldn't have to know what their idea was or judge its value or anything. If they thought it was a good idea and they wanted to go ahead with it, we'd give them the resources to do it. And over the past, I'd say, well, certainly over the past 10 years, there have been all kinds of new web searches springing up. I think back to 1996, and I think web crawler was the main search engine at the time. And then there's Alta Vista, and then there was Google, and so forth, and it keeps on going. But aside from these major search engines, there's lots of smaller things in different niches, and you can see some of them listed up here. And all of these companies have to solve the same problem. Anybody who wants to do any one of these things has to figure out, how do I crawl the web? How do I rack computers? How do I serve this stuff? How do I do parallel processing? Same problems in academia. If you wanted to do large-scale graph analysis, for example, where do you get the resources for that? Back in 2005, I was at SIG-IR in Brazil, and somebody asked, there was a paper published that says that the graph of the web looks like a bow tie with a strongly connected center, many sites that link in and many sites that link out. That paper was written about 10 years ago. If you didn't work at Yahoo or Google, could you figure out whether that's still the case? And it's not easy to figure that out now. But if you have access to 10 billion pages, you can come up with a pretty good idea. And so what we were doing is making available the data to answer those kinds of questions. So with that in mind, we launched the first version of the search platform. And this is a portal-driven collection of resources where you log in, and you get access essentially to a cluster of computers, a set of development computers, an area to store your output, and then 10 billion documents that we've collected. A little bit more detail, there's 10 to 15 billion pages, a set of Linux machines that we rented out for $1 per CPU hour, which is pretty cheap, network, $1 per gigabyte transferred, local storage for $1 per gigabyte per year, and then you could also serve search results based on new services that you built. This is essentially what the workflow was. You choose the documents that are of interest to you. You write a single function that can process one document. We then invoke that across every document that's of interest to you. You schedule your application to run across our set of machines. We put the output in a home directory, and then you can publish that. So it was pretty simple. I'm going to take you through a particular example that I really liked. There was a guy by the name of Rainer Tipke who developed a website called Musopedia. And it was a melody search. And you could go to this website and launch a Java applet, and you could sing a song to your computer. And I'm not a singer, so I'm not going to inflict that on you. But if you could even get the up and down sequence of notes, sing the same note, then go up and then go down, then it could identify that melody. And he had developed this based on volunteer work. Over a period of about 5 years, he had accumulated 35,000 melodies by people entering them manually. And so with our search platform, he could just say, give me all the files in your collection that are MIDI files and bigger than 1 kilobyte. Then he would write a single program that would extract the melody from those files and then write the output to his directory. So I'm sure you can't read this, so I'll just describe it for you. Essentially, you start up here, and you choose criteria, and there's up to 50 of them. You can choose by MIME type, document size, sites that link to a page, sites that are linked to from a page, phrases, keywords within the page. The list goes on. And so you come up with a set of criteria by which to filter the 10 billion documents. So here he chose 1 kilobyte documents that are MIDI files. We say, OK, we've got about 1 million of those. And he said, all right, that's the collection I want to work with. And then he said, I'm going to choose 10 computers for 4 hours. And this is my program that I'm going to run across the pages that I've chosen, which I'm going to call melody parse. And then I want you to put my output in this directory. I'm going to enter my email down here, and just email me when the job starts and email me when it finishes. And so he did, extracted his melodies, and here's what we've got. And so Yellow Submarine, for example. He found a couple of files on the web, yellowsubmarine.mid, and he extracted the melody, and he said first 4 notes are the same, then it goes up 1, then it drops a few, and then it's the same 4 notes in a row. And that's, I guess according to his results, that's 24 seconds into the song in this particular file. And so it's not a text search, but it could be viewed as being somewhat similar to a text search. You could also do this on audio files. You chose MIDI files because they're smaller and easier to parse, but you could do the same kind of thing with audio files. So with this simple 3-step process, he could get hundreds of thousands of melodies into his collection rather than the 35,000 that he had spent 5 years collecting. He didn't have to crawl the web to do it. He didn't have to understand cluster computing. He didn't have to do any of the operations behind all this. And so it was a huge success for him. So this was about 1.5 years. And how many people here have heard of this? Have heard of the search platform before? Okay, a couple of hands. So it didn't quite turn the world on its ear. So why aren't there 10 million new search engines? Well, we learned a few things. We learned that developers want what we call toolboxes instead of Swiss Army knives. This was an integrated portal where we told you what the workflow was, and you had to do fairly little work, and we would take care of all the back-end stuff. But we found that people wanted their own operating systems, their own tools. They didn't want graphical user interfaces. They wanted APIs that they could use. They wanted ways to share their work. They wanted public-facing computers. This was a set of computers behind a firewall, and you had to log in to get access to them. They wanted public-facing computers. So in a lot of ways, it didn't quite do what everybody wanted. And if you have a solution that does 90% of what you want, but not that final 10%, then it's kind of hard to actually be successful with it. A final problem was the pricing. We told people what these things were going to cost, but then they would ask us questions like, how do I know if I want 10 computers or 100 computers? Suppose my job runs for 10 hours and then stops, but it's not quite done. Have I just lost all my work? If I get a bill for this at the end of the month, is it going to be like my cell phone bill where suddenly there's all these surprise charges that I didn't quite anticipate? So they wanted to have better understanding of what the pricing was. So we went back to the drawing board, and now we have, in a month, we're going to announce this. So you're hearing it here for the first time. This is what we plan to do starting a month from now. We're going to build on top of services that are provided by Amazon. We're going to get rid of the, getting rid of the portal part here. And it's all just going to be APIs and web services. And Amazon, who owns us, has been very active in the web services and developer space. They've got about 160,000 developers now signed up for their web services. And they're working on problems that are very hard to solve for the individual developer, things that they've become very good at over the past 10 years. And so one of the things that they provide is storage. They have a service called S3, which is a storage service that allows you to do 3 things. You can put data, get data, and delete data. And you can build other services on top of that, but that's all that particular service does. They have another service which is called EC2, or Expandable Compute Cloud. And you can just sign up for computers, and unlike the problem that we were trying to solve, which was how do you schedule reservations for a relatively small number of computers, they said let's forget about the scheduling problem and just deal with the scarcity problem, which is have so many computers that you can get one anytime you want, as many as you want. And so you just say, I need 100 computers for 5 hours. Oops. Sorry. You can say, I want 100 computers for 5 hours, and I want this version of operating system and this set of tools. And they just create them, and 5 minutes later, you can use them. Use them for as long as you want. When you're done, you give them back, and they charge you 10 cents per CPU hour. Queuing. If you're trying to do large cluster computing jobs, it's useful to be able to share information without having computers blocking on each other. If you've got one computer that generates work, it can put it in a queue, and another computer that needs to do work can pull things out of a queue, and then you can coordinate their activities. This one I love. And it's very useful in doing search type things, which I'll come to. But the idea, the name here, Mechanical Turk, was based upon an early idea for artificial intelligence. There was a computer built, I guess, close to 100 years ago. I say computer, it wasn't quite a computer, called the Mechanical Turk. It was a chess-playing machine. It actually had a human hidden inside. So people felt like they were playing against a computer, but it was actually somebody hidden inside. And so what this service does is give you a programmatic API to humans. So you create a task that you want a human to do that's hard for a computer to do. And so it could be image recognition, it could be transcription, it could be all kinds of things. You take a little piece of work, you call this API and pass it to it, and then a human who wants to do work for money will do it for you. And there's a couple of services available on the web right now, one called Casting Words. And what they do is take podcasts, take a 10-second chunk out of a podcast, and send it to a human and say, tell me what this said. And so rather than trying to write software that understands language, they just take chunks of language and give them to humans, and they type them in. And if there's any ambiguity, they can send the same chunk of data to several people and then aggregate the results. And so this is useful in search, for example. If you wanted to have 100 people QA your search, you could say, which of these results is better? Or which sets of results are better? And just farm these things out. And then people, for fairly low prices, will just say, these are better, those are better, whatever. And then the next is our search service, which is the part where you said, give me all the documents that match these criteria. Then lastly, the web information service, which is a service that we provide that tells you anything you might want to know about a particular URL. What are the pages that link to it? How long has it been on the web? What's its size? What's its MIME type? What does it link to? How much traffic does this site get? And so with this set of web services, you can scale things up to thousands of computers or hundreds of terabytes of storage if you want, and it's very reliable and very low cost. So essentially, what we're planning to do is take 1 billion pages that we think are the most important billion and put them in this storage service. And then you can ask, give me the pages that match these criteria, and we'll tell you where to go in this storage service to get them. You can then fetch them to your compute nodes, do what you want, and create your output. So this, in the end, is roughly what it's going to look like as opposed to the previous slides. Via a web service, you sign up for a set of compute nodes, as many as you want. Once you've got them, you can start passing queries to this search and say, give me documents that match certain criteria. And depending on the number you ask for, we'll either give you back a list, or we'll take that list and stick it in S3 for you. If you wanted 1 billion documents, it's not very useful to get them sent to your screen. So we will just put them in S3 for you. You can then fetch them out of there, process them, and put them back in the user store yourself. And then these computers can be running whatever servers you want. If you want to use open source or Apache or a server that you've written yourself, this can then be queried by the public. And there's a huge and active open source community that's working on tools on top of these things. So one of the things that people are working on, if all of these computers are completely busy and you're falling behind in the amount of work you process, there's a publicly or a service written by a third party that will automatically instantiate a new computer for you and give it more work to do and keep adding them until either you run out of money or you run out of computers or you run out of work to do. If you've got too many computers and half of them are idle, it'll give them back. And so you can scale these things up and down depending on how much work you want to do or how many results come back or any way that you like. And so, as I say, for 10 cents per CPU hour, this is mighty cheap. That's cheaper than we can run computers ourselves. If you remember in that first slide, I said this is where our computers are. Our computers aren't going to be there for that much longer because as we retire computers, we're going to sign up for computers in this service instead. And so essentially, doing things on a web scale just got a whole lot cheaper. I mean, we thought it was cheap a year ago when we were charging $1 per CPU hour. Now we're charging 10 cents. And if you can write something to process a single web page, you can now parallelize that across hundreds of nodes and millions of documents. So if you've got an idea, here's how you can try it out. Again, I don't know what the future is going to be, but I think that you probably do, and this is a way that you can actually go and try it out for yourselves.
Thank you so much, Niall. Question? Do you have time for a couple of questions, please? Introduce yourself and also your affiliation.
Hi, Niall Kennedy, independent.
Niall.
Yes.
How often does that happen?
I have a question about the freshness of your index.
Mm-hmm.
You mentioned take the 1 billion most popular pages
Right.
Online, and you'll be continuously updated.
Right.
What do you define as continuously?
Every day?
And all 1 billion pages every day? Or
No.
how often you do?
No,
the
we'll have a
crawl
window of
cycle?
1 billion pages. Then currently we crawl about 100 million pages a day. We'll take a fraction of those that we think are the most important, put those in S3, and then delete some from probably up to 2 months ago.
So the new program is to change in your crawl. You used to say 2 to 3 months, and you just take a snapshot and make it available. So you're also changing that behavior.
Right. What we did in the past was take 2-month snapshots, start over, take another 2-month snapshot, and we've moved towards more continuous crawling. Snapshots are very useful for people who want to compare things across time. But what we found from our beta test is that people said, I would like something as close as I can get to the web as it is right now in a box. I don't care what it was 2 months ago or 6 months ago. All right? Another question?
How do you deal with just please, just to make a microphone.
Hi, John Gale, outside the university. How do you deal with copyright issues in terms of the documents?
Deal with copyright issues in terms of the documents?
Right. In other words, if you're supplying a document to me that somebody else holds copyright for.
Well, we can just give you, I mean, it's similar in a sense to the cached pages that you can get from any search engine, except that you can get more of them. And so if users don't want their documents to be in there, we'll take them right out. Or if they said in their robots.txt file that they didn't want us to crawl it, then we wouldn't have crawled it. So there's certainly precedent for that kind of thing.
Adam Chire at SRI. So first I want to just thank you and Alexa and Amazon for making available such services, because a lot of search engines these days, Google and others, are actually reducing a lot of the support for developers in terms of this. You know, you can't get a Google key as easily as you could before. There's often restrictions for like Google desktop search. You can query the results, but you can't actually display them in a different order than presented. You know, things like that. So I think it's pretty exciting that Alexa and Amazon are actually encouraging developers to get involved. So thank you for that. One question I have is, in the first version of your web service platform, it was actually hard to parallelize. So you could select a collection of documents and then run one program across all of those pieces. But if you wanted to run sort of like a MapReduce or some kind of operation across sets of pages at the same time, that was very difficult. Do you think the new platform will start to provide support for doing operations like this?
Are you saying it was hard based on experience, or?
I think so. I mean, I was trying to do this. There wasn't base support, at least a year ago. In terms of the model, it was sort of a sequential model where you could get kind of an output, and you could call the index, but there didn't seem to be much support for being able to do sort of MapReduce style operations where you're really gathering, doing queries across lots of pages at the same time.
Well, there's a couple of pieces to the answer to that. The original idea was that we would take care of all the parallelization for you and then combine your output in whichever way you wanted. So in a sense, it was kind of a MapReduce model. And so if you said run this across 30 computers, we would take your program and feed it pages on all of those 30 computers and then combine all the output. So the map function, in a sense, was the program you were writing, and the reduce function was the combiner. And you could say, I just want them thrown together in any old order. I want them sorted, unique, these kinds of things. So that was built into the original platform. There was also the ability to add new frameworks to the platform. If you said, I just want a bunch of computers and I'm going to put my own tools on them, you could do that. It wasn't quite so easy. And then there was a third party that wrote a MapReduce framework, which basically does what MapReduce did. And so it was hard for people to share those tools, which is why we're going more to this model. And so I don't know if Doug's going to tell you about Hadoop and other kinds of things, but if you want to use Hadoop, if you want to use MapReduce, if you want to use whatever, people can share tools and do whatever they want. And they can share data, output, all kinds of things. And so it'll open it up a bunch more to people sharing those kinds of ideas.
Great. Let me just one comment and we ask the next speaker. So So let me just predict the future, but no pressure on you. 6 months ago, when we invited you here, so you said $1, and now today is 10 cents. So I think I predict that 6 months from now that I invite you here, you're going to say that it's going to be 1 cent.
1 cent.
So, Peter, there's no pressure on you. Next 6 months again, we invite you here, it's going to be again another 6,000 to be higher. Okay, thank you so much, Niall. And let's just one more time.